Question 1a. We begin by opening the brackets in the numerator by applying the power to every term within the brackets, giving us 4a, 2 times 2 is 4, and b to the power of 2. Next, we take care of the negative power by inverting the fraction within the brackets and changing the power to a positive power. Next, we have to open up the brackets. Applying the power to the terms in the brackets, we have b to the power of 3 over 2 to the power of 3 is 8, a cubed. Then we multiply the numerator to give us 4a to the power of 4, b to the power of 5. Multiply the denominator to give us 8. 8 to the power minus 3 times a to the power of 3 will give us a to the power of 0. Then we simplify further by cancelling the numbers to give us 2 in the denominator, and applying the law of indices, we have a to the power of 4 minus 0, which is just a to the power of 4 in the numerator. Similarly, b to the power of 5 minus 2 will be b to the power of 3 in the numerator. This completes the question. We now move on to question 1b. In order to do the division, we must make sure that this term is expressed in an index form. The root of a number is just simply a power of half. Next, we apply the power to the terms in the brackets. So we have 36 to the power of half and a to the power of half. Thirty-six to the power of half is just simply the root of 36, which is 6. Then we have a to the power of half divided by 2a to the power of a quarter. 6 divided by 2 is 3, and a to the power of half divided by a to the power of 1/4 is just simply half minus 1/4 according to the law of indices. Half is just 2/4, so 2/4 minus 1/4 is 1/4. This gives us the result, 3a to the power of 1/4. In question 2a, we need to compare the size of a red blood cell to that of an influenza virus. To do that, the number of times is equal to 8 micrometers divided by 130 nanometers. We convert both to meters. 8 micrometer is 8 times 10 to the power of negative 6 meters. And 130 nanometers is 130 multiplied by 10 to the power of negative 9 meters. So we divide the numbers to give us 0.061538, and then dividing the powers of 10, we have 10 to the power of negative 6 minus negative 9 to give us 10 to the power of 3. Next, we need to reduce our answers to 3 significant figures, which is 6.15 multiplied by 10 to the power of 1. When we multiply by 10 to the power of 3, we move the decimal place 3 times forward to give us 61.5. And 61.5 will have to be written as 6.15. Therefore, we have 6.15 times 10 to the power of 1. In the next example, we need to factorize out 10 to the power of x. So we need to split this term as 10 to the power of x times 10 to the power of 2 plus 5 times 10 to the power of x. Now we have a common 10 to the power of x, which we can factorize out. Therefore, here we have 6 times 10 to the power of 2, which is 600, plus 5 times 10 to the power of x. So this is 605. To find 10 to the power of x, we divide away 605 to give us 100. And 100 is just 10 to the power of 2. Therefore, x must be equals to 2. Question 3a. We must factorize 3x squared minus 14x plus 8. To factorize, we need to make use of the factors of the first term and the last term. The factors of the first term is 3x multiplied by x. And the factors of the last term is 2 times 4, which is 8. To check whether the middle term is correct, we multiply across like this to give us 2x and 12x. So in order to get negative 14x, we need both to be negative. That is negative 2 and negative 4. So that negative 2 times negative 4 will give us positive 8. Hence or otherwise factorize this expression. Notice that this expression here is similar to the one in the first part. Therefore, we rewrite this using the factors which we have found. When we examine the factors, we see that there is a common factor of x minus 4. So we can factorize out the common factor. Having taken out x minus 4, what is left now is 3x minus 2. And on the other side, taking out the factor x minus 4, we left behind x plus 3 in brackets. Simplifying this, we have 3x minus 2 minus x minus 3, which we reduce it to 2x minus 5. Question number 4. Make x the subject of the formula. Since we have a fraction on both sides, we begin by cross multiplying. Multiplying diagonally, we have y multiplied by 2x minus 1 equals to 3x. Next, we open up the brackets. 2x y minus y equals to 3x. Since we want x to be the subject of the formula, we need to bring all the x terms together. Therefore, we have bringing 3x over will be negative 3x. We do not want negative y, so we bring it over to get a positive y. The subject of the formula must only be alone and by itself. Therefore, we need to factorize out the x so that there's only one x. So to find x as the subject, we divide away 2y minus 3. If you get your answer as y over or negative y over 3 minus 2y, there will be too many negatives. To take care of this, you need to take out the sign in the denominator so that you can reverse the term to 2y minus 3 and thereby cancelling out the negative sign, giving us the same answer, y over 2y minus 3. In question 5, we must solve two simultaneous equations. We label one as equation 1 and the next equation as equation 2. The equations are not in a proper form, therefore we need to rearrange it. From equation 1, we have 2x minus 2 equals to 3y, and we rewrite it as 2x minus 3y equals to 2 and call this equation 3. Similarly, from equation 2, we cross multiply, giving us x minus 3 equals to 4y, and again rewriting it, we have x minus 4y equals to 3, calling it equation 4. Now we have our x terms, y terms, and the number in the correct order. From here, on examination, we need to create a common term which we want to remove. In this case here, I want to remove the x terms, therefore I need to create a 2x. I take the equation 4 and multiply by 2 to give us 2x minus 8y equals to 6. This is equation 5. Next, I take equation 3 minus equation 5. Equation 3, we have 2x minus 2x is 0, and 3 minus negative 8y, which gives us 5y. And here we have 2 minus 6 is minus 4. Simplifying, we have y equals to negative 4 over 5. Then we substitute the result y equals to negative 4 over 5 into one of the equations. Let us substitute into equation 4. So we have x minus 4 bracket negative 4 over 5 equals to 3. And simplifying this, we have x equals to negative 1/5. Therefore, the solution is x equals to negative 1 over 5 and y equals to negative 4 over 5. In question 6, we must add two fractions. Before we add the fractions, we need to examine whether the x terms are in the correct order. In the first fraction, the x term is in front, and in the second fraction, the x term is behind. Therefore, the first thing we do is to make the x term in front. To do that, I change the sign in front to negative, and then I change the order of the terms in the denominator. Next, I need to factorize the denominator. Factorizing 4x squared minus 9 gives us 2x minus 3 times 2x plus 3. Now we take a look at the denominators, and we see that we do not have a 2x plus 3 here, so we multiply by 2x plus 3 to give us 5 times 2x plus 3. And on this side, we doesn't have 4, so we multiply by 4 to give us 12. So now the denominator is the same. This is now 4 times 2x minus 3 and 2x plus 3. We need to simplify the numerator. Multiplying in using the distributive law will give us 10x plus 15. 5 times 3 is 15 minus 12. Do not open up the denominator. Okay, 15 minus 12 is 3. So we have 10x plus 3 over 4 bracket 2x minus 3, 2x plus 3. In 7a, we need to multiply 2 terms by 3 terms. To do that, we take the first term in the first brackets and multiply it by every term in the second brackets. Next, we take the next term, which is 2, and multiply by every term in the second bracket. Okay, using the distributive law, we expand it. Then we need to simplify it by collecting the like terms. We have 2x cubed, and here we have minus 3x squared plus 4x squared will give us plus x squared. 5x minus 6x will give us a minus x plus 10. In 7b, we need to open up the brackets and simplify the expression. This is a perfect square. When we expand the perfect square, we have 3 terms, which is 4a squared minus 4ab plus b squared. Minus, when we multiply this, the result must be kept in brackets. A times a squared, minus ab plus 2ab will give us a plus ab. Next, we have minus times plus is minus, b times 2b is 2b squared. Then we open up the brackets and change the signs. To simplify, we need to collect the like terms. 4a square minus a square will give us 3a square minus 4ab minus ab to give us minus 5ab. b square plus 2b square will give us 3b square. In question 8a, we must simplify an algebraic fraction. Before we simplify, we must first take out the common factor, which in this case is 2 bracket 4x squared minus 25. Similarly, we have a common factor of 6. We take it out and we have 2x squared plus x minus 10 in the denominator. Now we can cancel out the common factor, giving us 3 in the denominator. In the numerator, we have a difference of 2 squares, which factorize to 2x minus 5 times 2x plus 5. And in the denominator, it factorizes to 2x plus 5 and x minus 2. Now we have a common factor, 2x plus 5, which is cancelled away, leaving us 2x minus 5 over 3 bracket x minus 2. We must leave our answers in brackets. In question 8b, we have another fraction, and this time we have a factorization by grouping in the numerator because there are 4 terms. Therefore, in the first group, we have a common factor of 2a and c minus d in brackets. Once we have a c minus d in brackets, we must make sure that in the second part, there must also be a c minus d in brackets. Therefore, in the second part, we have negative 3b is common. In the denominator, we see that d is common, so we factorize out d, giving us 3b minus 2a. Now we can see that there is a common factor of c minus d in brackets. We take out c minus d, giving us 2a plus minus 3b in brackets. You can see that 2a minus 3b and 3b minus 2a is reverse. Therefore, we need to take out the sign in order to make it the same so that we can cancel it off. So we take out the sign, put it in front. This becomes 2a minus 3b, which can be cancelled out. Now the answer is c minus d over negative d. There are too many negatives, therefore we need to simplify it further, and we can actually simplify it very easily by changing the sign for every term. C is positive, we change to negative, negative we change to positive, and negative change to positive. This is the final answer. Question 9a are two equations on indices. In the first equation, we have a fractional power. To solve a question with a fractional power, we need to make this power into 1. To do that, we need to apply the reciprocal power. The reciprocal power is 3 over 2. We apply it to both sides of the equation. Now the power has been reduced to 1, giving us 2x, And here we need to express 9 as 3 squared, so that when we multiply the power, 2 is cancelled out, leaving us 3 cubed, which is 27. Whenever we take the root, especially for even root, we must make sure that we take care that there are two answers, plus and minus. Therefore, the answer dividing by 2 will be plus and minus 13.5. In question 9b, we can see that we have an unknown power. To solve a sum with an unknown power, we make a common base. That means we are expressing all to base 3. And 1 is expressed as 3 to the power of 0. Now we have a common base. 3 to the power of 2n plus 2, and multiplication we add the power. So we have the same base. We can equate the power, giving us 2n plus 5 equals to 0, which is 2n equals to negative 2.5. In question 10, we have another sum on indices. We are given two sets of values. 5 to the power of x minus y equals to 1/5, and 5 to the power of x plus y equals to 125. We must make use of these two values to solve the sum. If you examine the first sum, you'll notice that it's quite similar to the first expression given. Therefore, we can rewrite it as 5 to the power of 2 bracket x minus y, and we can write it as 5 to the power of x minus y bracket to the power of 2. Remember that in power to a power, we can multiply the powers, giving us this. Now we can make use of the value 1/5 and put it to the power of 2. Remember to put it in brackets. 1/5 square is 1/25. In the second expression, we can rewrite it by taking 5 to the power of x minus y multiplied by 5 to the power of x plus y. In this way, when we multiply and applying the first law of indices, when we add the power, we will have x plus x to give us 2x, minus y plus y will be 0. So there's only 2x. Therefore, the result is now 1/5 times 125, which is simply 25. Now we move on to section B, question 11. This is a question on speed, time, and distance. So we will be using this formula. Speed equals the distance over time. We are given the speed and the time and the distance, from which we can form the equation speed times time equals the distance. The speed is 20x plus 15, and the time is x hours. The distance is 225. Okay, then we expand it. 20x squared plus 15x equals to 225. We need to get this equation, so we make the right hand side 0. And we divide throughout by 5. Dividing by 5, we will have 4x squared. Dividing by 5, we have 3x here. And dividing by 5, we have 45, giving us the same equation as required. Next, we must solve this equation. Therefore, we need to factorize it. Since it can be factorized, factorizing it will give us x minus 3 times 4x plus 15 equals to 0. There are two solutions, x equals to 3 and x equals to minus 3 3/4. Since we want to find the time is equals to x, which is 3 hours. Since the other value is negative, it is rejected because time is not negative. And in the final part, we are asked to find the speed at which he traveled. The speed at which he traveled is 20x. So since we found x to be 3, then we have 20x is 20 times 3 plus 15, giving us 75 kilometers per hour. In question 12, we have a sum which leads us to two simultaneous equations. In the first part, we have to form two simultaneous equations from the information given. This sum is about the cost of tickets and the number of seats. We are given that the cost of the front seats and the back seats are x and y, and if we have 3 front seats, the cost will be 3 times x, and 2 back seats, the cost will be 2 times y, and when we add them together, we will get a total cost of 105. Similarly, the cost of front seat is x, 5 front seats will be 5x, and 4 back seats will be 4y, and this gives us a total of 185. This gives our two equations as required. In part B, we must solve this equation. To solve this equation, we need a common term in y, so we need a 4y, and we get it by multiplying the first equation by 2, giving us 3x times 2, 6x, plus 4y equals to 210, equation 3. Now we have a common term in y. We can subtract equation 2 from 3. That is equation 3 minus 2. 6x minus 5x is x. 4y minus 4y is 0. 210 minus 185 is 25. Then we substitute into equation 1. to give us 3 bracket 25 plus 2y equals to 105, and simplifying this will give us y equals to 15. Therefore, in part C, these are actually the values of each type of ticket. The front seat cost $25, that is X, and the back seat cost $15, that is the value of Y. In the last question, we have a length of cloth 200 meters, and this is being cut into strips of x plus 2, a length of x plus 2, and if we cut it into lengths of x, we will have an extra of 5 pieces. Therefore, in the first part, if we want to find the number of pieces of length x, it's just simply taking the whole length and divide by the length of each cloth, each piece. Similarly, to find the number of lengths which are x plus 2 meters, we just take the total length, divide by the length of one piece. Now, since the number of pieces is 5 more, that means that the difference in the number of cloths is 5, thereby giving our equation. We need to show that the equation is reduced to this. Therefore, we must make a common denominator by taking this, multiplying by x plus 2 over x plus 2. And on this side, we need a factor of x, so we multiply by x over x. In this way, we can put this into a single fraction over the same denominator. We have 200 x plus 400 minus 200x. Okay. Simplifying this, 200x minus 200x is 0, giving us 400 over x times x plus 2. Okay, multiplying, cross multiplying, we will have 5x bracket x plus 2 equals to 400. Then we open it up and make the right hand side 0. And divide throughout by 5. Thereby getting the required expression. In the next part, we need to solve the equation. Since the equation can factorize, we can factorize it to x minus 8, x plus 10 equals to 0, thereby giving us two answers, x equals to 8, x equals to negative 10. And since x equals to negative 10 will give us a negative length, therefore we reject it. Therefore, the length of the cloth of the longer piece, which is x plus 2, which is just x 8 plus 2, which is 10 meters. Since length is not negative, we reject -10. That ends the paper. Thank you.